In this video, we are going to examine how the graph of rational functions look like. F of x is a rational function because the numerator is a polynomial and the denominator is also a polynomial. To graph, it is easier if we simplify f of x first. So to simplify, we need to factor both numerator and denominator. So here I have the factored form of f of x. Looking at this factored form, let us determine the zeros of the denominator. So what values of x make the denominator 0? So the denominators there are two factors, x plus 4, and so we set it equal to 0. Therefore, x is equal to negative 4. This tells us that negative 4 will make the denominator 0. So if I plug in negative 4 here plus 4, that's going to give us 0 times negative 4 minus 4, which is negative 8. Negative 8 times 0 is going to give us 0. So negative 4 makes the denominator 0. All right, so there's another factor in the denominator, which is x minus 4. And we want to find out what will make it 0. So x minus 4 equals 0 becomes x equals 4. So when we plug in 4 into x, this denominator here becomes 0. Now, after we factor, we are going to cancel common factors. So we will cancel the x minus 4. And so the simplest form now is y equals 3 over x plus 4. Now, after canceling the common factor from the numerator and the denominator, what is the 0 of the denominator? So in this simplest form, what's the 0 of the denominator, or what makes the denominator 0? So that's going to be x plus 4 is equal to 0. Therefore, x is equal to negative 4. So in the simplest form, negative 4 makes the denominator 0. But in the factored form, before we cancel the common factors, there are two zeros in the denominator, which are negative 4 and positive 4. Now, let's take a look at the graph of f of x, and let's see how it looks like. All right, the graph of f of x is a hyperbola. And each part, there are two parts. There's this curve, one part, we call this a branch. Here's another branch. And this graph is discontinuous. And there seems to be a boundary between the two branches. And it seems that this boundary is at x equals 4. So if I put here x equals 4, oh, that's not positive 4. It should be negative 4. X equals negative 4. If I make this broken, that is the vertical asymptote. Now, if I look at the graph, I see that the horizontal asymptote is y equals 0. Let's make that broken. And that looks like it's the horizontal asymptote. Okay, now, so the vertical asymptote seems to be at the value of x that makes the denominator of the simplest form equal to 0. Now, what is in the other 0 of the denominator, of the original denominator? That's x equals 4. So let's take a look at what is at x equals 4, which is right here. Okay. Oh, right here we see an hole, an open dot, a missing point. So at x equals 4, there is a hole in the graph. And 4 is the value of x that makes the factor that we canceled equal to 0. Can we make conclusions about this? Now let's graph g of x. So the first thing we want to do is to factor the numerator and denominator. Numerator cannot be factored anymore, but denominator, since it's a difference of two squares, becomes x plus 3 over x minus 3. So again, let's find the zeros of the denominator. So that's going to be negative 3 and positive 3. Now we cancel. We can cancel 3 plus x and x plus 3, and therefore the simplest form is y equals 1 over x minus 3. Now what's the zero of the denominator? The zero of the denominator is x equals 3. So originally there were two zeros, but one of the factors got canceled. So in the simplest form, there's only 1 0 in the denominator. Now let's take a look at the graph. The graph is again a hyperbola, and we see that there's a vertical asymptote and a horizontal asymptote. The vertical asymptote is at x equals 3. So let's check if it's really at x equals 3. Okay, let's put here x equals 3. Oh, that's where the vertical asymptote is. Let's change the color of that. And it seems that the horizontal asymptote is at y equals 0. Okay, so now we notice that the vertical asymptote is at the 0 of the denominator of the simplest form. Now, what is at the 0 of the denominator that was canceled? And that is negative 3. So if we look at negative 3 in the graph, negative 3 is right here. Again, we see a hole in the graph at x equals negative 3. So just like the previous function, the 0 of the factor that we canceled represented a hole in the graph, and the 0 of the denominator of the simplest form, we see there the vertical asymptote.